Today's paper is Staring into the Abyss, an evaluation of concurrency control with 1000 cores. It's a 2014 paper. This paper presents a scalability evaluation of 7 concurrency control schemes on a custom in-memory OLTP database using a CPU simulator called Graphite, which scaled up to 1024 cores. It led to identification of bottlenecks in concurrency control schemes that are independent of DBMS implementation, and authors argue that even the state-of-the-art system suffers from these limitations. 7 concurrency control schemes evaluated in this paper are two-phase locking with deadlock detection, two-phase locking with non-waiting deadlock prevention, two-phase locking with wait and die deadlock prevention, basic timestamp ordering algorithm, multi-version timestamp ordering, optimistic concurrency control, and timestamp ordering with partition-level locking. In this paper, Graphite CPU simulator for large-scale multi-core system was used. Graphite was deployed on a 22-node cluster, each with dual-socket Intel E52670 and 64 GB of DRAM was used. Authors implemented their own lightweight main memory database management system based on pthreads to run in Graphite. It executes as a single process with the number of worker threads equal to the number of cores, where each thread is mapped to a different core. All data in DBMS was stored in memory in a row-oriented manner. The system supports basic hash table indexes and a pluggable lock manager that allows to swap different implementation of concurrency control schemes. It also allows indexes and lock manager to be partitioned or run in centralized mode. The workloads used in this paper are YCSP, that is Yahoo Cloud Serving Benchmark, which is a collection of workloads that are representative of large-scale services created by internet-based companies. Around 20 GB of YCSP database containing a single table with 20 million records was used. Each YCSP tuple has a single primary key column and then 10 additional columns, each with 100 bytes of randomly generated string data. DBMS creates a single hash index from the primary key. The other workload is TPCC. This McMarch is the current industry standard for evaluating the performance of OLTP systems. It consists of 9 tables that simulate a warehouse-centric order processing application. All of the transactions in TPCC provide a warehouse ID as an input parameter for the transaction, which is the ancestral foreign key for all tables except item. For a concurrency control algorithm that requires data processing that is edge-stored, TPCC is partitioned on warehouse ID. There are 3 key contributions of this paper. A comprehensive evaluation of the scalability of 7 concurrency control schemes, the first evaluation of an OLTP database on 1000 cores, and the third is identification of bottlenecks in concurrency control schemes that are not implementation specific. Now let's give this paper a PS score. This paper is very engaging read, so it gets 9 out of 10. It's around 11 pages long, which is kind of perfect for the content, so it gets 9 out of 10. Reproducibility might be hard, so it gets 8 out of 10. Industry value is quite high, so it gets 9 out of 10. I learned quite a few new ideas from this paper, so it gets 9 out of 10. The overall PS score is 9 out of 10.